Today's lesson will be our first opening lesson on multiplying polynomials. But before we get to that, I'd like you to pause the video and try these first two sections of review. The first one being reviewing combining like terms from earlier this week, and then also the second one reviewing some exponent rules when we're multiplying variables. When you're done, you can click back in and take a look at the video to check your work. Okay, so you should have already done this, but just to double check and review here. Example 1, there's only one x squared term, so 7x squared. We have 5x and -3, so plus 2x. And in this case, the 7's cancel because you have plus 7 minus 7. The second example, we've got a -9x cubed and a positive 3, so -6x cubed. We only have the -8x and the -6, so -14x squared. Then the other two terms that remain are singletons, so plus 6x plus 4. And note here, the important part from this is that we're not doing anything with the exponents. So when you combine like terms, you're simply adding or subtracting the coefficients. Whereas in the second set of review, this is where we have to add the exponents. So if you forgot that rule, keep the variable the same, but for example 1, this is really y to the first power. So when we add 1 and 4, we get y to the 5th. The second one, we add the 2 and the 4, getting x to the 6th. And then the third one, bringing in the coefficients. Here we're going to multiply the 3 and the 6. And then we're going to add the 3 and the 1 that again is not shown. So that should be a 4. So we're going to need both of these skills to be able to multiply today. So if we scroll down here a little bit on our notes, we're going to be talking about two different techniques for multiplying. You may have heard of the FOIL method before, maybe not. We'll go over that first, and then I'll also show you how to use a box to do multiplication, and that's going to translate a little bit beyond just this lesson. So first, the FOIL method. FOIL is actually an acronym, which means each of the letters stands for a word to help us remember the kind of the ordering of how we're going to be multiplying. Note that this only works for a 2 by 2, meaning a binomial times another binomial. And in our first example, you can see we've got binomial x plus 4 and then binomial x plus 2. The way this works is we just break down the letters of FOIL and follow the order that it tells us. So the F stands for first. And in this case, that means we're going to multiply the first two terms. So we're going to take x times x, and I'm just going to note that over here. X times x is x squared. The O stands for outside or outer. So now we're going to take the outermost term, so x times 2. And we're going to write that a little bit cleaner, the way we like to see it, which would be 2x. The I stands for the opposite, inner, or inside. So the innermost two terms would be the 4 and the x. All right. And then the L stands for the opposite of the beginning. This time we're going to be multiplying the last, so the very last two terms. So in this case, 4 times 2. And now if you want to put in the little eyes here, we've got our funny FOIL face to help us remember the ordering of multiplication. Now, you may be thinking, well, that doesn't really look like anything we've seen before, because why would we ever write a polynomial like this? Well, the short answer is we won't. And after this first example, I probably won't write it like this again, where I'm showing all of the steps. I'll just write out the terms in the order that we multiply them. But what we're going to do at this point is now we're just going to combine like terms. So first we multiplied, we used that exponents rule where we're multiplying variables and numbers together. And now we're going to add using combining like terms properties. So in this case, we have an x squared term. We have two x terms, the 2x and the 4x. So we'll just add those together to get 6x. And then we have the 8 as the add-on at the end. That would be our final answer for this first one. Let's go ahead and take a look at another example of this before we take a look at what the box method looks like. All right, so we're going to take a look at example 1, and then I'll have you try example 2 and 3. So using the FOIL technique, again, F stands for first, so we're just going to multiply the 2x and the 3x, so that'll get us 6x squared. The O stands for outside or outer, so 3x times, don't forget the signs here, -5, so that would be -15x. The I stands for inner or inside, so negative 7 times 2x would give us negative 14x. And then L stands for last, so negative 5 times negative 7 would give us positive 35. So multiplication is done. Now we just need to clean up these inner two terms, and we'll have 6x squared minus 29x plus 35. And that would be our simplified final answer. So again, I'd like you to pause the video and I want you to try using the FOIL method for examples 2 and 3, and then you can come back to the video to check your answers. All right, so example 2, you should have had 2x to the fourth. Here we have x squared times x squared plus 3x squared minus 10x squared minus 15. And again, those middle two terms, noticing a pattern here, won't always happen. But our middle two terms combine. So our final answer, 2x to the fourth minus 7x squared minus 15. Note again, when we're adding or combining like terms, the exponents do not change. All right, now, maybe you were a little puzzled what to do with example 3 because it doesn't look like the other two. The problem here is that they're squaring the quantity, and what that means, remember that to square something means to times it by itself. So this really means take another y minus 3x. So now we can compute the FOIL. In this case, we're going to get y squared minus 3xy minus another 3xy, and then plus 9x squared. If you tried to multiply without doing the squared concept, maybe you just thought about distributing the squared sign like we would with exponent rules, you'd completely miss these middle two terms, which again end up being our like terms that we have to combine. So y squared minus 6xy, again, don't add those variables together, just the coefficients. And there is our final answer for example 3. All right, so now we're going to go back to the front and we're going to talk about the second technique that you might choose to do this, which is the box method. All right, so our last technique for basic multiplication is the box method. In this case, we're going to look at the same problem we did with our FOIL, but now we're going to use, obviously, the box method. And the box method can be used beyond just a 2x2 because the beauty of the box method is we can build the box to whatever size we need. So since, again, in this case, we're going to be multiplying the x plus 4 and the x plus 2 together, we need a 2x2 box. And what that means is we're just going to make a square. And we're going to put in a big plus sign. So then we have, in this case, 2 slots on this side as well as 2 slots along the top. And all we're going to do is we're going to put one of the polynomials across the top, so the x and the 4, noting here that both terms are positive, so we don't have any signs shown. And then on the side, we have the x and the 2. Now, some of you might recall lattice multiplication, and before you think good or bad, whether you knew or understood that, if you liked lattice, this might seem familiar. It might seem more comfortable. If you didn't like lattice, that's okay. You can use FOIL and then kind of an add-on to that when we get into later multiplication. But if you're familiar and remember how to do lattice, this is going to be somewhat similar. Now, the rules of the box are this. You multiply to get in the box. You add to get out of the box. And what that means is we're just going to take the first 2 terms here, the x times the x that build this first box, and multiply those together. So that gets us x squared. Then we take the 4 and the x from over here on the left, and that gets us 4x when we multiply those together. Then we take the x up here, the 2 over here, and that gets us 2x. And then lastly, we take the 4 and the 2 to build the last box, and that gets us 8. Now, you might be thinking, wait a minute, we just saw this with the FOIL technique, and you're absolutely right, which would make sense because we're doing the same problem. Here again, now that we're inside of the box, it doesn't look like a normal polynomial. So how do we go about writing it? Well, all we're going to do is look inside the box and combine like terms. So again, notice that in this case, our like terms are the 2x and the 4x, just like they were with the FOIL. And we have that x squared term and that positive 8 that we just have to add on. So our final answer, again, I'm not going to rewrite it, but should be the x squared plus 6x plus 8. So back to page 2, we have the bottom section where now I'm going to show you one more example of box, and then I want you to try the box method for the following 2, just to get practice with both concepts before we mix it up a little bit. All right, so again, remember the box is defined by the size of the polynomials you're multiplying. So for example 1, we've got 5x minus 6, so that's 2, times 2x plus 1, another 2. So again, that's what's defining the 2 by 2 sized box. So over here, I'm just going to make that kind of window-shaped box. And then one of the polynomials, it doesn't matter which, I'm going to put the 5x and the negative 6 on the top, which means the 2x and the positive 1 go on the side. And again, multiply to get in the box. So I'll switch colors here. We've got 2x times 5x, giving us 10x, add the exponent squared. 2x times negative 6 will get us negative 12x. And then 5x times 1, just 5x, and 1 times negative 6 makes that negative 6. Here again, we're looking for like terms to come out of the box. So I note that the diagonals are the like terms. This won't always happen, but in this case, it does continue to occur. So when we combine, we've got that 10x squared term. I'm going to write it in that standard form we talked about before. Negative 12 and positive 5 will give us negative 7x, and then negative 6 just on the end. All right, again, go ahead and pause the video at this point and try examples 2 and 3 and come back when you're ready to check. So you should have paused. Example 2, let's mix it up. I'll put the 2x squared minus 5 over here and the x squared plus 1 over here. So 2x to the 4th, 2x squared, negative 5x squared, and negative 5. And combining like terms, we get 2x to the 4th minus 3x squared minus 5. And here again, that last example, if you recall from the top, we want to make that another 1 plus 4x, since that's what it means to square something. I'll make my box down here. So easy here, we're going to have the same thing on both the side as well as the top. And we get a 1, 4x, 4x, and 16x squared. And again, order doesn't really matter. I won't write this one in standard form. I'll go in the order of the box. We've got 1 plus combine like terms to 8x plus 16x squared. So super important on both example 3s that we're noting. You should not be squaring the terms inside. You do have to complete the FOIL or box process.